Greetings. Welcome to our 51st episode of the FGI podcast series. My name is Tim Stark, and I'm a professor of civil engineering at the University of Illinois at Urbana-Champaign. On today's episode, we're going to focus on our December 12, 2023 webinar titled Analysis of Geocomposite Drainage Layers, GDLs, for Landfills and Ponds. I'd like to quickly reintroduce our distinguished speaker, and that is Bob Mackey. Bob is a partner, senior design engineer, and senior project manager with S2L Inc., a consulting engineering firm specializing in waste management issues and waste containment facilities. Bob has a broad experience in solid and hazardous waste issues. Bob is also past chair of ASTM D35 Committee on Geosynthetics, former technical program chair of various geosynthetics conferences, and also a former adjunct instructor at the University of Central Florida. So Bob, thank you so much for joining us again from Orlando, Florida.
Okay. Well, you're welcome. And actually, I'm doing this from an ASTM meeting in Louisville right now.
Oh, I was there on Monday. Had to bail out for a hydropower conference. Okay, so Bob, we had questions remaining from your webinar that we didn't get through at the end. And we also received a number of questions in the follow-up survey that's sent out after each webinar. So you have a number of questions, which are all good to address today. So let me start with the questions from the live webinar. Number one, what would be the difference between single and double-sided geocomposites in terms of drainage and interface friction angle?
All right, well, a single-sided geocomposite, or CDN, only one side will allow the textile to intrude into the opening area of the geonet. So you would probably have some increased drainage. It depends on how you use that single-sided. Usually that you use a double-sided when you have a textured geomembrane, and you would use a single-sided only to try to save cost. And what happens is that by going with a single-sided, you're relying on the disparity height of the geomembrane to cause enough frictions to the ribs of the CDN. That's going to be quite a bit less than having what we call a Velcro effect, where there's a textile bonded to the CDN and lying on the geomembrane, the textured geomembrane. For the slip to occur, you're stretching the fibers of the geotextile, and you have to break those fibers. On a single-sided, you're going to, if you want the thing to slip, then the nubs of the CDN or the geonet is going to have to rise up and over the asperity of the textured sheet. So I would think there would be a difference in interface friction angle between the two, and you should test for that to see if you needed to go with a double-sided CDN and a textured sheet to achieve your interface friction angle for slope stability.
Yeah, all good points, Bob. One other thought that they may have in mind with this question is, what happens if there's a GCL on top of the witness zone, and the witness zone consisting of a geocomposite? So there the net would be in contact with the GCL, which may actually embed a little more in the GCL than with a double side.
Well, that is true. You're always worrying about what the GCL is made of, what textile. Mm-hmm. So some textiles are woven on one side and non-woven on the other, and you would worry about extruding the bentonite through that textile into mm-hmm. the geonet. And if you had another geotextile associated with the CDN, then it's less likely for that bentonite to extrude through both textiles.
Absolutely. Okay, Bob, great, thank you. Next question from the live webinar that we did not get a chance to answer is, How can we reduce the amount of organic matter in the subgrade to help the geomembrane and the rest of the layers from lifting in ponds or stormwater basins?
Well, it's a costly answer is that you have to remove the organic material.
Right. Yeah.
Okay. I mean, any organic material is going to decompose over time, and it had to be pretty significant to generate so much uplift. But I've done liner systems before where they actually had to go and remove the organic material, not necessarily for the uplift of a landfill, because there's a lot of weight within a landfill. It's just that there's a lot of differential settlement that could stress the liner system, and you want to have a solid foundation for some of these facilities.
Yep. Okay, number 3. In Saskatchewan, Canada, there are general concerns of using CDNs as primary drainage layers in MSW landfills due to biological clogging. What are your thoughts?
All right. This is not a simple issue. It all depends on time dependence. Like our landfills in Florida, for example, we start at one end and we build cells laterally, like in a rectangle on out, so that the major impingement rates onto the liner system is usually in the first 5 to 10 years. Now, if you're building say a borrow pit landfill where you start placing the waste in the bottom and it's going to be accepting leachate for 30 years over on top of that CDN, then you really need to boost up the capability of the CDN in its performance over time. Now, when it comes to biologic clogging, there's another consideration. The biologic clogging will occur in the textile, but it would also occur on the surface of your protected soil over the CDN. If you're using gravel or drainage rock, great. I mean, then that's less likely to occur, and then your biologic clogging is going to be along the textile. But if you have a drainage sand in particular, that's going to clog first, and then your head's going to start building up over the over that clogged area. And once the head starts building up, you'll get leakage via Darcy's equation down through the drainage sand and into the CDN. So yeah, you have to look at it on a case-by-case basis of how long is it going to operate, what are the materials above it, and then calculate what you think your biological clogging is going to be and put the appropriate safety factors associated with it.
Okay, great. Number 4, we're working on a geomembrane cap or closure project, and the previous design had a CDN over the geomembrane and then a low permeability soil placed over the CDN. What should we design this CDN to? The design impingement rate is low because of the cover soil properties, but there may be a situation during construction that the CDN will need to convey more liquid than the design. Conversation with the client.
A low permeable soil, I think of clays, and I worry about the clays clogging the textile, so that your thickness of your clay layer is going to be included in the textile itself. And is it going to be so saturated at times that the clay may weep into the geonet and thereby close down its capacity? I've never heard of clay, low permeability soil, placed over a CDN. Most soils over the CDN are a drainage soil with a little more higher permeability, and then the clays are a protective layer over the drainage soil above it. So you should design it for that impingement rate you think is coming out. If the soil in the clay comes very saturated, you're probably not going to get slope stability within the textile of that CDN. It's going to be probably along the interface or within the actual clay structure matrix. And that would be my concern of using clay over a CDN.
Yep. Okay. Great, Bob. And now I'd like to turn to the questions we received during the follow-up survey that was sent to everyone after your webinar. And there are a number of these questions. So, number one, what is the difference between the single-sided? I think we answered that.
Yes, it's a little bit different here. It's the same previous question that the answer is applicable, and it says, would you recommend double-sided as a drainage material? And I say absolutely. I recommend double-sided. I like the ability of what's called the Velcro effect and the strong friction angle between the composite drainage net and the geomembrane.
Yep. So for the listeners, the first part of the question is the same as question number one from the webinar, which is, what is the difference between the single-sided and double-sided geocomposite in terms of drainage and interface friction angle? Would you recommend double-sided as drainage material? And Bob just said yes to that. Okay, Bob, number two from the follow-up survey. Why don't you use geotextile filter criteria to specify the properties of the upper geotextile component of the geocomposite for the type/gradation of soil to be placed on top? We'll just do that question, and I'll ask you the second part.
All right. Well, what I would do is that you don't really design the composite drainage net. You accept what the manufacturers produce out there, and you design or specify the soil to be placed on top of the geotextile. Now realize that this woven geotextile that's being bonded to the geonet, it's going to go a little bit of changes. It's going to lose some of its porosity because of the heat bonding process. So you really should be specifying the soil to be placed on top and not designing the geotextile to be bonded to the geonet.
Yeah. I mean, I guess they could be a special order for sure, but yeah.
Then it would cost, and then the manufacturer's not going to be very comfortable with that because it's not a product they've used before.
Yeah. Okay, second part of this question is, also, if there is a bottom geotextile component, what are the design requirements depending on the underlying layer? For example, a geomembrane, GCL, or compacted soil?
Well, if there is a bottom textile component, the design requirements are just the same as the top component. I mean, you're looking for peel resistance, 1 pound per inch. You like to see the geomembrane liner be textured. The GCL, you want that additional textile to keep the GCL from the compacted layer from intruding into the geonet.
Okay. Number three, what is an acceptable height for grass to avoid clogging of the geocomposite?
I think I addressed this a little bit within the webinar, but you want to see how well they're maintaining your closure. You want to see the grass being kept trimmed and mowed on a regular basis. The idea that if you see plants that are growing a couple feet high, the roots are going to go pretty deep.
Right.
But the difference is that grass is always going to want to seek where moisture is contained. So if you have a soil matrix below the grass that is very consistent and retains water, during times where you go to the dry seasons, the roots are going to extend down into the moisture. So you really like to have your upper layer, a topsoil layer that's of lower permeability than what your drainage layer or your protective layer over your CDN. And you thereby give kind of a capillary break so that the roots don't find water acceptable underneath the topsoil layer.
Right. Okay. Next question. Testing of CDN for flow rates at elevated temperatures and simulating landfill basal conditions has shown a significant reduction in performance, which varies for different structures. Should reduction factors proposed in literature thus be quoted for a specific temperature and a specific type of product? For example, the geonets that you were talking about, the dimpled geomembranes, and the what are called spaghetti cores or intertwined core.
Well, I don't know enough about variation in temperatures within a landfill. My understanding is that the temperatures will range along the bottom liner system about 130 degrees Fahrenheit. Sometimes it's about 5 degrees more, 5 degrees less. So that's a very moderate temperature range. It's only when it gets up higher that you start seeing more creep within the composite or the GeoNet polymer. So I don't specify any kind of temperature requirement. What I would do is just make sure from the testing apparatus or information received about the GeoNet structure that you do the calculations through the GRI standard guide that they have produced on calculating creep, and use that to determine your reduction factors or your safety factors according to creep in that regard.
Yeah. So, Bob, I've written some papers on elevated temperatures in landfills and measured as high as 180 degrees, or actually 185 degrees Fahrenheit. So it can get higher. So
yes, can I ask, is that temperature within the core of the landfill or at the liner system?
Liner system, thermistors down the leachate risers.
Okay, good. I find that in Florida we have pretty hot landfills because of the organic nature and the high moisture content, and we didn't see those high temperatures. So it's a rather unique case.
Yeah. Okay, but they should look at the type of waste they have and think about the temperature range that could develop, such as if they're taking aluminum dross or other reactive material. Yeah,
right. Absolutely. And my concern when we did our study at a landfill in Florida is that is the leachate bringing the heat down with it to the bottom liner system. And when we tested the temperatures down there, we didn't find it. We saw a belly affect the higher temperature within halfway down, and then it cools off the closer you get to the bottom liner system.
Yeah. Okay, Bob, next question, number 5. One thing we struggle with is the best way to specify geocomposites for landfills to get what we need without sole sourcing. Thinking about potential differences in manufacturers' values for creep, etc. Any thoughts on how best to do this specification? What properties to require and what testing should be required in the specifications?
All right. There's one thing I do that a lot of regulators get a little confused on, is that I don't specify a thickness of our composite drainage net or the GeoNet. What I specify is I do what kind of transmissivity I need for the overbearing waste. And it could be at the maximum waste amount, volume or height of waste, or it could be in that first lift. And I run the test, or have them run the test based on what I need to perform within my design, utilizing the reduction factors and safety factors that have been calculated. So I only care about that transmissivity. And if you can get me a material that gives me the transmissivity, and I know the loads and the impingement rates that it must function, then I'm satisfied. I don't care if it's 200 mils or 250 mils, just give me the transmissivity.
Yep, right. Yep, specify the transmissivity and let the manufacturers meet it. Right. Okay, great, Bob, thanks. And number 6, is there a need to run the HELP model, which is the hydraulic evaluation of landfill performance, if you know the cover soil's permeability?
All right. Now, this question doesn't say, is this for a top cap or a bottom liner system? So let's make it clear. You should not use.
Yeah. They say cover soil. I'm thinking final cover, but you're right. You're right.
Yeah. So let's make it very clear that you should not use the help model for final cover design. It's been proven that there's been failures that the help model underestimates the impingement rate through the cover soil. Within the cover soil, if you know what the least permeable layer is, that should be sufficient to determine your impingement rate. And Rick Teal and someone else did a paper on this years ago and got awards for that approach. And it's been used throughout the industry. Now, if it's a bottom liner system, you need the help model because you have no way for the leachate to run off. It's going to mound up, and you need to know how much is going to be driven through the drainage layer or that cover soil layer to the geomembrane. And that's where you get your impingement rate and calculate your spacing of your leachate collection laterals.
Right. Okay, number 7. Are there any advantages for using a geocomposite drainage layer for animal waste storage? I think the goals are pretty similar to landfills, keeping waste contained, releasing built-up methane, and having a leak detection system, for example.
Well, a leak detection usually is a double liner system. So having a composite drainage net underneath the primary is a good idea for the leak detection system. When it comes to the storage of animal waste, that's pretty sludgy stuff and can clog that textile. So you'd almost need to have a cover soil, protective soil layer, drainage layer, separating the animal waste from the composite drainage net. In the release of methane buildup, well, that causes when you're capping the landfill. And I guess it could probably permeate through that cover soil down into the CDN. And yes, you would probably want to try to release that methane within your drainage layer anyway, especially when this methane or this gas pressure starts building up in your leachate collection system. It has a tendency to cause what's called vapor locks or vapor plugs. They're not going to drain appropriately. So on the upper end of the leachate collection system, it should be vented to the atmosphere or vented to your landfill gas collection system with a slight vacuum so you don't get these vapor locks within your drainage system.
Okay. Number 8, and the last question from the follow-up survey, Bob. In the United Kingdom, we carry out the flow capacity test using flat platens, and this is the transmissivity test you talked about, rather than site-specific soils. Is this acceptable?
Well, I have never heard this, and so it happened that I'm at ASTM, and I saw this question, and I called over George Kerner with the GSI, and I say, hey, George, have you heard this? And he goes, yes, they do it in Europe. And the reason they do it in Europe is that it's part of the ISO standard, and what they have found is shipping soil from one country to another to be very problematic. So they have 2 different platens. They have a soft platen for Ottawa sand, and they have a harder platen for the low permeability soil. And you have to specify what platen you want to use. The ISO test method has great reducibility and repeatability. Repeatability be doing a test over and over again in a lab and get the same results. The reproducibility is getting the same results from different labs. And then you don't have this sidewall effect of soils that you want to intrude into your transmissivity machine. So it's an excellent accepted standard. If that's what the regulators require, I would say go ahead. It is acceptable. The only caution I would give is that these platens represent 2 specific soil types. And if the cover soil you're using over the composite drainage net is not similar to Ottawa sand, say it has some rocks in it that may have a more focused point that may intrude into or push that geotextile into this geonet, then you might want to increase your safety factors or reduction factors for that variable soil and how it might affect the flow of your system. And if it ever comes too much concern, some variability within that cover soil, you may want to go back to using the cover soil within the transmissivity test.
Right. And Bob, the soft platins are top and bottom of the composite or just on the top?
Good question. They're on top and bottom.
Yeah. Okay. Great. Bob, thank you. Those are all the questions. Thanks again so much for joining us from warmer than here, Orlando, Florida. And thank you to all who submitted these excellent questions and for attending the webinars. So Bob, great job, and thanks for attending again.
My pleasure.